Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0101 refers to an issue with the mass airflow MAF sensor in the Honda CR-V, specifically indicating a circuit range or performance problem. This DTC suggests that the signal from the MAF sensor is out of the expected range, which can affect the vehicle's fuel management and engine performance. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, allowing the Engine Control Module, ECM, to adjust the air-fuel mixture accordingly. Located between the intake air duct and the throttle body, the MAF sensor is essential for optimizing engine efficiency and reducing emissions. If the MAF sensor is not functioning correctly, it can lead to various performance issues, including poor acceleration, increased fuel consumption, and potential engine misfires. Properly diagnosing and addressing this DTC is vital for maintaining optimal vehicular performance and emission standards. The MAF sensor, or mass airflow sensor, is critical for measuring the amount of air entering the engine to ensure an optimal air-fuel mixture. It's typically located in the intake duct assembly, positioned after the air cleaner and before the throttle body. The sensor sends real-time data to the Engine Control Module, ECM, which utilizes this information to adjust fuel injection and timing. If the MAF sensor signal is outside the expected range, it can lead to incorrect calculations of air volume, causing lean or rich engine conditions that negatively impact fuel efficiency and engine performance. This error might also trigger not only the P0101 code, but potentially other DTCs related to air intake performance. Proper troubleshooting of the MAF sensor and associated components is necessary to rectify performance concerns linked to this code. The DTC P0101 can be triggered by several factors that impair the MAF sensor's ability to function correctly. Firstly, poor connections or damaged wiring leading to the MAF sensor can prevent proper signal transmission to the ECM, leading to miscalculations. Components associated with the air intake, such as the PCV valve, intake air duct, air cleaner, and purge line, can also contribute to this code if they are damaged or not secured properly. Additionally, restrictions in airflow, whether from a clogged air cleaner or an improper installation of intake components, can lead to inaccurate readings. Every component plays a significant role. Therefore, it is essential to assess each one meticulously during troubleshooting to ensure an accurate diagnosis of the issue. When DTC P0101 is triggered, drivers may notice several symptoms that indicate issues within the intake system. Commonly, poor acceleration performance may manifest, where the vehicle does not respond as expected during acceleration. Increased fuel consumption can be another visible symptom, as an improper air-fuel mixture can lead to overfueling or underfueling conditions, thus affecting overall fuel efficiency. Furthermore, the activation of the check engine light serves as a warning to the driver that a diagnostic trouble code needs attention. The MAF sensor directly influences engine performance, and any malfunction can also lead to rough idling or inconsistent engine behavior. Being aware of these symptoms can lead to early detection of problems related to the MAF sensor. The first step in troubleshooting DTC P0101 is to conduct a thorough parts condition check. This involves inspecting several components, including the positive crankcase ventilation, PCV valve, the PCV hose, the intake air duct, the air cleaner, and the purge line, as well as any connections between these components and the throttle body. It's crucial to look for any signs of physical damage, such as cracks or loose fittings, as these issues can disrupt performance and alter the sensor readings. Ensuring solid electrical connections is paramount. Even minor corrosion or wear can cause significant problems. After verifying that everything is in good condition, you can proceed to the next troubleshooting steps to pinpoint the cause of the DTC P0101. The second step requires a visual inspection of the intake air duct, specifically checking for any damage or looseness. The intake air duct is essential because it directs the airflow from the air cleaner to the engine, and any issues here can drastically affect MAF sensor readings. A compromised duct can allow unmetered air to enter the system, leading to miscalculations by the MAF sensor. Look for signs of wear, cracks, or loose fittings that could lead to airflow disruptions. If any damage is detected, the air duct should be reconnected or replaced to ensure a proper seal and consistent airflow into the engine. Once this step is complete, we'll move on to the next in the troubleshooting protocol. The third troubleshooting step involves checking the air cleaner element for dirt accumulation. The air cleaner is responsible for filtering incoming air, which is vital for the engine's health. A dirty filter can limit airflow and alter the readings from the MAF sensor. Inspect the air cleaner element visually for any signs of dust or debris that could obstruct airflow. If the element is found to be dirty, it should be replaced immediately, as this is a common and simple issue that can affect performance. After ensuring the air cleaner is clean, you can continue on to the next troubleshooting step for further diagnosis related to DTC P0101. In the fourth step, begin by turning the vehicle to the on mode without starting the engine. Using the Honda Diagnostic System, HDS, check the MAF sensor parameters, which should exhibit values between 520 and 10,000 Hz during operation. It's essential to compare the current conditions with the expected thresholds to verify that the MAF sensor is working within the required specifications. If the actual readings align with the prescribed thresholds, it's an indicator that the MAF sensor is likely functioning correctly in this instance. Should the values fall outside this range, this points to a malfunction in the MAF or intake air temperature IAT sensor, requiring replacement. This step helps diagnose if the issue lies specifically with the sensor itself. Step 5 necessitates starting the engine and allowing it to idle while continuing to monitor the MAF sensor signal using the HDS. Again, you should check for readings that indicate proper operation, ideally falling between 520 and 10,000 Hz. This step is crucial because while the engine is running, various conditions affect how the MAF sensor operates, and identifying discrepancies in readings can confirm underlying issues. If the signal is within the specified range, it suggests the MAF sensor is working appropriately, whereas readings outside this range would indicate a malfunction, prompting the need for sensor replacement. This further supports the accurate assessment of the MAF sensor's condition while under operational circumstances. The final step involves verifying whether the problem persists after clearing the DTC with the HDS. Start by turning the vehicle off before turning it back to the on position to proceed with clearing the code. Once cleared, start the engine and hold the engine speed at 3,000 RPM without load until the radiator fan activates. Then allow it to idle for at least 5 seconds. Subsequently, drive the vehicle at a consistent speed of around 37 miles per hour for a minimum of 5 seconds. After performing these actions, check for any pending or confirmed DTCs. If DTC P0101 reappears, it indicates that the failure persists, warranting the replacement of the MAF sensor or IAT sensor. If no codes are present, it suggests the problem may have been intermittent, so also check connections at the sensors and the powertrain control module, PCM. This thorough process ensures comprehensive verification of the MAF sensor system's health. Following the troubleshooting steps, it's pivotal to execute a final repair verification. Ensure that all identified fixes have been carried out effectively, whether it involved replacing the MAF sensor or repairing any damaged parts. Next, conduct a scan for DTCs to confirm that no codes, including P0101, reappear. It's also recommended to take the vehicle for a test drive under various conditions to check for performance issues. During the test drive, monitor the vehicle's responsiveness and fuel efficiency to gauge improvement. Ensuring that no codes return after these checks solidifies the repair work's effectiveness and confirms that the MAF sensor system is operating as it should. To avoid future occurrences of DTC P0101, preventive maintenance strategies are essential. One effective measure is to regularly inspect and replace air filters when they become dirty or blocked to ensure optimal airflow to the engine. Conduct routine checks on connections leading to the MAF sensor to detect any early signs of wear or corrosion that could lead to performance issues. Additionally, promptly replace any damaged or worn components within the intake system to prevent any disruptions to sensor readings. Implementing these practices helps maintain the health of the MAF sensor and ensures that the engine runs efficiently, ultimately extending the lifespan of the vehicle's components and enhancing performance. In summary, DTC P0101 indicates a problem within the MAF sensor circuit, requiring systematic troubleshooting to determine the exact cause. Understanding the role of each component in the air intake system is critical for effectively diagnosing such issues. The troubleshooting steps highlight the importance of inspecting, testing, and verifying each element, from the air filter to connections leading to the MAF sensor. Regular preventive maintenance can play a significant role in minimizing the likelihood of DTC occurrences by ensuring components are in good working condition. Keeping a close eye on performance and swiftly addressing any related concerns supports optimal vehicle function and longevity. Please like and subscribe to the channel. See you next time.